Hi guys, I am Mohan, Director of SUDHIR NEET Biology Academy. I am really happy to meet you for a short video on the heart sound, cardiac output and stroke volume. This is also an important area in the circulatory system. So regarding the heart sound, there are two sounds, love and dove sound. Love sound is made by the closure of di- and tricuspid valves. So, by the closure of AV valves, dicuspid and tricuspid valves, the love sound takes place. It is of longer duration. So, you should note down these points. So, I am telling you point by point for your convenience to memorize easily. So, it is of longer duration. It lasts from 0.16 to 0.9 seconds. The sound is fairly louder. Then the second sound is the dove sound. This is caused by the closure of the semilunar valves. It is of short duration. It lasts for only 0.1 second. It is a softer sound. This is enough if you know the timings, etc. about the two sounds, heart sounds, love and dove. Then next we come to the cardiac output and the stroke volume. There is another important point note here. The cardiac output. So what do you mean by the cardiac output? It is the volume of blood it ejects out per minute. That is the cardiac output. How will you calculate the cardiac output? So cardiac output equals to the stroke volume into the heart rate. Stroke volume is denoted by the volume of blood ejected per beat, per one heartbeat. Heart rate is the total heartbeat per minute. So by multiplying stroke volume and heart rate, we get the cardiac output. I once again repeat for your convenience. So cardiac output is the amount of blood pushed out, the volume of blood per minute. Note down. Stroke volume is the volume of blood per one heartbeat. Heart rate is the total number of heartbeats per minute. So cardiac output equals stroke volume into heart rate. For example, normally we will have 4,800 ml of blood. That equals 60 ml stroke volume into heart rate, normally for example 80. So 80 into 60 ml, it comes about 4,800 ml. Under pressure and under stress, when the heartbeat increases, for example 120 beat per minute, then the cardiac output also will increase. 120 into 60, that equals 7,200 milliliter. So this is how we calculate the cardiac output. How will you calculate the stroke volume? The stroke volume is calculated by the formula EDV minus ESV. That is, EDV is the end diastolic volume and ESV is the end systolic volume. Let us see. Ventricle gets 100 ml of blood but ejects only 60 ml of blood. The remaining blood is 40 ml. So 600 ml is the end diastolic volume and 40 ml remaining is the end systolic volume. So stroke volume is equal to EDV, end diastolic volume, minus end systolic volume. 100 minus 40, that equals 60 ml. So this is about the cardiac output and stroke volume. Speaking about the stroke volume, it depends upon three factors. This you must know. One, contractility of the muscle. The contractile power of the heart muscle. That is, if there is more force, then more blood is ejected out. Number one. Number two, preload. When the ventricle is filled with blood, the ventricle wall stretches with the pressure. That is called the preload. So if you push air inside the balloon wall stretches to a maximum. Likewise, the preload is the ventricle. When the ventricle is filled with blood, the ventricle wall stretches with pressure. Then afterload, this is the resistance of ventricle to eject blood. So to a particular stage, the elasticity remains, after which the elasticity has to go. So before that, afterload, the ventricle resists the pressure to eject the blood out. Now the ventricular pressure should be more than the vascular pressure of the pulmonary artery and aorta, so that the blood from the ventricle will flow into the pulmonary artery and aorta. So thank you very much.